Went with purple. All right. All right. Last one we're looking at is problem number 21. Now, luckily for us, problem number 21 is the bottom, the denominator of this fraction is already factored completely. We have x to the third and x squared plus 1 squared. Well, x squared plus 1 does not factor any further than this. Now, for our x to the third, the denominators for it, we would have x squared, and then x to the third. The x squared plus 1, well, we would have x squared plus 1 to the first, and then x squared plus 1 squared. So we have 5 possible fractions for this here. On top of these, with our x, we'd have a, x squared, we'd have b, x cubed, we'd have c. It's a, b, c. X squared plus 1 would be, not a, because at this point we're up to dx plus e, and lastly we'd have fx plus g. So we have a lot of terms in this one here. And again, just like we've been doing, we're going to multiply by the denominator of our first term. Now the nice thing is that this one here on the left, everything's going to cancel. And leave us with x plus 1. Now with a, one of the x's is going to cancel on top and bottom, leaving us with a times x squared times our x squared plus 1 squared. Plus, with our b, 2 of the x's are going to cancel, leaving us with just x, so bx times x squared plus 1 squared. Plus, the c, the x cubed and x cubed will cancel out completely, leaving us with c times x squared plus 1 squared. Here, the x squared plus 1 will cancel out with 1 of the x squared plus 1, leaving us with plus dx plus e times x cubed times our x squared plus 1. Now, one of the nice things about having this on the computer and on the paper is I can move the whole thing. But then we're left with also plus here. All that cancels, leaving us with fx plus g times x cubed. So this one here is one of the longer ones and a lot more steps to it. So this one, in problems like this here, is going to be important to keep track of all your terms. Now the x plus 1 squared, really what we're talking about is that we have x squared plus 1 times x squared plus 1. Plus we have it showing up in 3 different places. And we are going to have to multiply that out. Now, dx plus e. Here, next we have x cubed times our x squared plus 1. Let's go and multiply that out. X cubed times x squared is x to the 5th. X cubed times 1 is x cubed. And down here at the end, we have fx plus g times x cubed. Well, fx times x cubed is going to be fx to the 4th. G times x cubed is going to be plus gx cubed. Because we're going to start trying to simplify where we can. Questions on this so far? Now, luckily enough for us, this multiplication, and this multiplication will all result in the same thing. Because x squared plus 1 times itself is still going to give us the same results, no matter where we have it put. Because x squared times x squared is going to be x to the 4th. X squared times 1 is going to be plus x squared. 1 times x squared is plus x squared. And 1 times 1 is 1. And we get this here. Now, for our next one, dx plus e times x to the 5th plus x cubed, we can go on and distribute that out. Dx times x to the 5th is going to be dx to the 6th. Dx times x to the 3rd is going to be plus dx to the 4th. E times x to the 5th is dx to the 5th. And e times x to the 3rd is plus e x to the 3rd plus fx to the 4th plus g x cubed. Combine like terms. Questions on any of this so far? So, do we understand what we did on the first step? Multiplying through. Really, from here, all we're doing is simplifying. But again, so I'm going to back up. Now, all I'm going to do is say this, because here, we were good up to this point, yes? Yeah. What are we doing here, here, and here? X squared plus 1 times itself, yes? There's nothing that says that we have to keep multiplying it out. Because I can come over to the side, x squared plus 1 times x squared plus 1. X squared times x squared is x to the 4th. X squared times 1 is plus x squared. 1 times x squared is x squared, and our 1 times 1 is 1. which is all three of these here. Yeah, not really, but that was more because we're running out of paper. But even with these here, we're just multiplying down and trying to get our terms. So x cubed times our x squared plus 1. X cubed times x squared, x to the fifth. X cubed times 1 is x to the third. And we're just multiplying through dx times x to the fifth. Still have d, x times x to the fifth is x to the sixth. Dx times x to the third. Well, we still have d. X times x to the third is x to the fourth. E times x to the fifth is e x to the fifth. E times x to the third is plus e x to the third. So really, even at where we had the middle steps, this is where we're at this point. We're just trying to multiply through and get all the terms out. Ax squared times x to the fourth is ax to the sixth. Ax squared times 2x squared is going to be 2a x to the fourth. Ax squared times 1 is plus ax squared. Bx times x to the fourth is going to be plus bx to the fifth. Bx times 2x squared is going to be 2b x cubed. And bx times 1 is plus bx. And the last set of multiplications we have is with cx. Cx times x to the fourth is cx to the fifth. Cx times 2x squared is plus 2cx cubed. And lastly, cx times 1 is plus cx. So, oh, here ex to the fifth and ex to the third. Are they like terms? Because one is x. We can if we multiply like bases, we can add the exponents. Because 2 to the 6th power, is that going to be the same as 2 to the 4th power? No. And if we added them, because 2 to the 5th is this, 2 to the 3rd, I'm just picking two numbers, is this. If we added the exponents, which would be 2 to the 8th, which is 256, 32 and 8 won't get us there. We just can't combine them, unfortunately. But that is all the multiplication that we're doing. Now we're going to group. So we're saying, so over here, we'll start with just our non-variable terms. When we plug the values of A, B, C, D, all those letters in, well, the variables are only, because like A to the 6th here, let me get a highlighter. So A to the 6th, we have an x to the 6th. The only thing that I can combine, possibly combine x to the 6th with, is another term that has x to the 6th. Because those are like terms, yes? Don't focus on the A, B, C, D, E, F, G. But the only variable I can add x to the 6th with is another term that has x to the 6th, yes? That's the only way we can add or subtract like terms. And those are the only two terms on this side that have x to the 6. Well, they would match up with our x to the 6 over here. But at 0, we don't have an x to the 6. So it's saying that 0 x to the 6, because that's just 0, should equal whatever a x to the 6 is plus our dx to the 6, because those should combine to give us the one on the left. Well, the next number we can look at is 5th. So we have, but also we don't have an x to the 5th on the left-hand side. But if we did, bx to the 5th cx to the 5th, then yes, ex to the 5th. If we combine those three for whichever values b, c, and e make that true, should give us the other side. But since it's 0, it kind of seems a little weird. Then we would go with fourths. Well, again, there is no fourth term. So the first one we're looking at is 2a x to the 4th. And I would just keep going through the whole thing plus dx to the 4th plus fx to the 4th. Still don't have an x cubed. But if we did, our 2bx cubed plus 2cx cubed plus 3, or x cubed, yeah, ex cubed, gx cubed should also give us 0. Now we're going to go to squares. Well, we don't have an x squared term still, so it's 0x squared is equal to ax squared. That's it. Then we move to x. We have an x, so x is equal to bx plus cx. That's it. Let's put this under the gx cubed, otherwise. Yeah. We don't have one because of the x cubed. It's just 1. There's none that match up with it, unfortunately. Yeah. Sure. Yep. You're going to hate this. No, it's not that we did it wrong. It should be just what? C.
Not CX?
Yeah.
Okay, well, I was like,
Yeah.
remember I had one thing, and
Yeah.
I had to change off the separate one and restart it.
So that was a typo on mine. So it should have been C, not CX. And for some reason, I did add that X. This.
That just changes from C to on or
So what that does, so since it's C, C times our X to the 4th
CX to the fifth.
should be CX to the 4th. And this here is going to be cx squared and c. So that's what that changes there. Now here, well, luckily we hadn't done any calculations yet because that would have messed things up. But it's going to make things a little bit nicer. And if you need an eraser, I can get you an eraser. Because for our x to the fifth, we still have bx to the fifth and the fifth, but no cx to the fifth, because c is with the fourth.
And then the 2cx cubed is squared.
And the cx cubed is squared.
Cx is just c,
Yes. Okay.
which is 1.
Gx cubed. So I'm going to just, for my insanity's sake, ax to the sixth and dx to the sixth we have here. Fifth, bx to the fifth, and ex to the fifth. Fourth, 2ax to the fourth, cx to the fourth, dx to the fourth, fx to the fourth we have. And then cubed, 2bx to the third, that one, ex to the third, gx to the third. Come down, now we're at squared. Ax squared plus 2 cx squared. X. We have bx. And that's it. And then 1 is equal to c. Now again, this looks a lot. And what's funny, I think it's funny, is this is actually about to simplify pretty nicely. Because what this tells us here is that c is 1. F, G. Yeah, we stopped at G. We didn't have H. So far we know C is 1. The 1 right next to it, X is equal to BX, yes? We do have X on either side. Yeah. So we can look at the one right next to it, 0, x squared is equal to ax squared plus 2cx, yes? So if we combine, because these are like terms and we could add them together, yes? Whatever a plus 2c is, those two numbers should add together to give us 0. Because we can combine like terms, they both have x squared, so whatever a plus 2c is should give us 0. Because they both have x squared, so we can combine those. A and c are just numbers. Well, what is c? So we're saying that a plus 1 times 2 is 2. So So whatever A is, when added to 2, should give us 0.
Oh, -2.
Okay. Well, I'm just going to look at x to the 6th. Because we know that these are both, again, like terms, yes? So the value of A and the value of D should add together to give us what? 0 still, yes? What's A? So -2 plus D should give us 0, yes? D is 2. Questions on this here? Now, it does seem I'm picking these equations at random to which one to solve next, yes?
Yeah.
But look back at this here, because we started here. C is 1, yes? Just by setting it up told me that. Also, just because of how it's set up, we could also find that B is 1, yes? So what variables do we know the value of? B and, when I looked over here at our x squared, what variables do we have? We have A and, I know C, yes? We can now solve for, because I'm only missing 1. I solved for A. And when I look back up here at the top, well, all the way over here at x cubed, we have B, E, G, yes? Well, I know B. At this point, it's 1. Do I know what E is? Do we know what G is? How many are we missing there? I can't solve for 2 at once. We can systems. I'm going to leave it for now. If we looked at our x to the 4th, we have A, D, F, C. At this point, I do know A value. I know D. I do not know F, but I do know C. So how many am I missing there? 1. We can solve that. So that there is showing as 0. I do not know. D's value is 2. We don't know what F is, but C we got as 1. 2 times -2 is -4, plus 2, plus F, plus 1. Well, the -4 plus 2 is -2, plus 1 is -1. Telling us that F is 1. So really the only things we're missing now are E and G. Our x to the 5th, well, we know B, we just don't know E. So 0 is equal to our B value plus E. So E is equal to, because 1 plus E is 0, 1 plus -1 is 0. And lastly is our x cubed. So 0 is equal to 2 times B. Well, B is 1. Plus E. Well, E is -1. Plus G, which is the only one we don't know. 2 times 1 is 2, minus 1 plus G. And G is,
We just like put in a parenthesis thing. Oh no, we have to plug it
Now at this point here, well, we have all that marked out. We would rewrite it back in. So down at the bottom, I'm going to make room so it's not scrolling back and forth. Or, well, yeah. Because our original expression, we had x squared, x cubed, x squared plus 1, and then x squared plus 1 squared. So we had a, and then b, c, dx plus e, but since e is -1, it'd be -1, and then fx, so 1x plus g minus 1. But I would say the hardest part
Is that up there?
of this is not so much any of the calculations, it's just keeping track of the terms. So again, you will have this here is the bonus.
How is the bonus?
Yeah,
Oh, okay. Okay.
and it's worth 6 points. So
How much?
6.
Is it of the 100 or is it?
So this is its bonus points, just this problem.
Yeah,
Yeah.
the test, because remember last test was like out of 200?
Yes, it is still going to be out of 200,
Oh, okay.
but you can get, if you get everything and the bonus, you can get 212 out of 200.
You got, that was so many. Whoa, that's pretty good.
But I think this here that is, especially once we start finding A, B, C, D, E, F, G,
Yeah, it's easier.
it solved itself. We don't have to do a system. We're not trying to solve for more than one at a time. It literally unraveled itself.